Alright guys, welcome to this part of the video. In this part I'm going to introduce this principal component analysis based on our previous step, which is the word to vector. So let's go to the code. So if I want to do a PCA, I must do the PCA based on some values. The values here is actually the vector's value. The vector's value. So in here is actually the model dot the word vector dot vocabulary. So the vocabulary here is actually the 200 words that we are emphasizing now. So the 200 words is what we did in the TF-IDF model that that we filtered, that we think that could be most related to the company location criteria. You see here, after I run this step, I see that I have 200 unique words, and the length of the labels. The label here basically just means the words. So how many words in here? 200 words. Label here is I append the word in the word vocabulary, and the tokens is when I convert it to the vectors. So the token here is actually the vector. So the length of the tokens should also be 200. So and here which is correct. So it should all be at 200. So let's look at what the label look like. The label is just look like this. So the labels is just the 200 words that we are working on now. And the tokens are a group of vectors, and in each vector there is 100 values. This 100 value, it's actually the ones that we set as the parameter in the word to vector model in here. You see here in our previous step in this model, I trained in the word to vector, Genism word to vector, trained as a model file in here, and I use the size parameter, which is the token size of the the vector size of the model to 100. So you see here, so for each word, when I transfer the word to a vector, so there are 100 values. So you see here that this is 25. This is 20 by 5 matrix in here. So that's altogether 100. So for each vector, this vector represents a word. And so with this vector, I can do a PCA. So in the next step is the PCA analysis. I use this sklearn package PCA to do the PCA analysis. First, we need to do an elbow test to see to kind of decide how many principal components we want to consider. So with this step, I can do this this elbow test. Normally, we see that where the elbow appears, that's where we want to set the number of principal components. But theoretically, we actually wanted to have accumulation of the percentage of variance that that all the PCs has explained. So I did a accumulation percentage of the accumulation. So which is this table. I see here that the first PC explained about 9% of the variance of all the data sets. So you see here this dots about 9%, and the second is about 6, third about 5, and this column is the accumulation of the first 3, and this one is accumulation of the first 4. So I can see. If I scroll down, so principally we wanted to have like over 85% of the variance to set the number of principal components. I see here it's around where the 85 is. So I see here it's just around like 45 or 40, 44 or 45 or 46 something principal components. So you see here, it looks like 45% principal components is the best choice. So I just set it to 45, and I compute the principal component value for each PC, which is this step. So you see here, I have this table out. So for each column, it's a PC, and each row actually represent a word. So you see here, I have actually 200 rows in here. If I print the the shape of this this data set, see, just print the row, which is 0. So you see here, it's just 200. Let's see, maybe it's 200. So this is actually what I want in here. Let's also show this. So maybe just print. Okay. Okay, so 200 rows, and this is the principal component table. And with this table, I can do the clustering. I can do the clustering just based on this principal component values. And the clustering step I'm going to introduce in the next video. Thanks for watching.